All right, hi there. Welcome to Algebra 2. We start off the year with some basics, pre-algebra verbiage that you learned in the past, just to refresh our brains because, summers get kind of long. We start off here with talking about the basic operations of mathematics, addition, subtraction, multiplication, and division. The key words you will see for those are going to be sum, difference, product, and quotient. The other ones will be used less and less, but you still might see them. The one that gets used a lot that actually causes some issues is this less than right here. When you see less than, kids tend to get it mixed up. Because right here I have an example of the less than. I said x minus 5 can be written as, and notice how I say 5 less than a number. This is the one case where you have to make sure that the thing that's written first, the 5, actually goes at the end. And it should feel right to you if I said, hey, you've got 5 less than $9. I would hope you would think, oh, let's see, 5 less than 9, that means I have 9 minus 5, I have $4. So you would think I'm actually going to put the minus 5 at the end. Everything else you can get away with just going straight left to right. If I say 4x, that means 4 times x. Could also be written as 4 dot x, right? We won't use 4xx anymore. We're done using x as multiplication. But you can use 4 dot x. Notice that that would be written as the product of 4 and the number. The 4 is first, and the number we don't know, x, is second. And here I have the quotient of a number and 4. I said the quotient means divide. Number is the thing we don't know, that's our x, that comes first, and then we divide by the 4. The one exception to that is up here, going back up, we have 5 more than a number. Really, I would be thinking the same as less than, and I would put x plus 5, or x plus 5 like I have here. But if you decided to do 5 plus x, that's the same thing. Right? 5 plus 2 is the same as 2 plus 5. So as you look through all these key words, just keep in mind that the one where you have to reverse the order is the one that has the less than. Very common mistake there to not do that. As you go to write from words into numbers and operations, you're going to want to use parentheses when you see some specific words up here. So a couple are already up here, but one that isn't up here that you're going to see is the word quantity. Q-U-A-N-T-I-T-Y. If you see quantity, you should be thinking what's ever written after the quantity is put in parentheses. You also are going to want to use parentheses when you see difference or sum. Okay? And you need to make sure you do that when you have multiple steps. Like if I said, what's the sum of a number and 5, you can write x plus 5, no problem. But if I say the sum of a number and 5 divided by 3, that's got multiple steps, then you need to make sure and put divided by 3, or you could put x plus 5 divided by 3. You could actually not have parentheses if you put it all on top, because they're not necessary. But if you want to put them there, go ahead. It just looks a little weird to me. Okay. Then we also want to be careful. We want to differentiate between more than and less than compared to is more than and is less than. And if you see is, so I got an is there, I got is more than, or if I had is less than, I didn't write the is less than, I just said is less than, or I just said applies to less than. If you had is, then you need to be thinking about inequalities. So this is 5. This is the greater than symbol. It points towards the small thing. The symbol always points towards the small number. So this means 5 is bigger than x. Right? See how that arrow's pointing at the small number? Always point at the small number. So that is 5 is more than a number. 5 is bigger than that number we don't know. Or you can say 5 is greater. Notice the is. You see is, you should be thinking inequalities. When it's greater than or more than, or less than. If you said just plain is, it'd be an equals. Okay, but if you have is more than, greater than, if you have is less than, use the less than symbol. If you just had is, like I say, hey, Joe is cool, that's like Joe equals cool. Okay. 5 is greater than or equal to x is the same as x is less than or equal to 5. Be written as a number is. See, I'm saying is because it's an inequality. Now it's pointing at the x, so that means 5 is bigger. Right? Both of these are pointing at the x, do the same thing. This 5 is bigger. But it can also equal. So can you come up with an expression that means the number is bigger? Or actually the number, I should say, the number is smaller, right? 5 is bigger, the number is smaller. So I want to say the number is smaller than 5. That would be less than, right? But it could also equal. So what do you say if you have so much money in your wallet, but it's capped at a certain number? I said the money in your wallet is less than or equal to 5. What could you say in words? Well, what you should be coming up with, a number is no more than. No more than 5. Could be smaller, could be all the way up to 5. And then on this next one here, I said 5 is less than or equal to x. That means my number is bigger, right? I'm pointing at the small number, I'm pointing at the 5. So the x is bigger. The unknown is bigger. So if I said, hey, in your wallet, you could have 5, but it could be more. What do you say? Well, hopefully you're thinking the number is at least. So when you see no more than or at least, that's going to give you these inequalities that have less than equal or greater than or equal to. So just some verbiage here to start with. Okay, let's do a few problems. So we want to go from words into numbers and expressions. This is 5 times the quantity. I'm just going to kind of break it up. I see times, so I'm thinking that's multiply. I see quantity, and if you go back, that should be telling you what? Maybe thinking, oh wait, I got parentheses. And then what's this mean? Okay? So I get 5 times the quantity of, well, let's see, let's just write this down. 5 times, and then parentheses. And then this stuff's got to go in the parentheses. 3 less than a number. Well, there's that less than one we got to be careful of. It doesn't say is less than, so it's not an inequality. It says less than. So 3 less than, what's 3 less than 10? Hopefully you're thinking 3 less than 10 is 10 minus 3 is 7. So we want to subtract the 3 from this mystery number, and when we don't know what the number is, we can just put x or n or whatever your favorite variable is. Right? So that would be good. You really don't need the dot in front there. You could have 5 times the quantity x minus 3 like that without the dot. Okay. So let's try to divide this up into sections, smaller sections, because this is really huge. This is a lot of words. It's a lot of reading. This is the product of 2 and a number. Well, product means times. So I'm going to multiply 2, and then I don't know a number, so I'll just go x. Okay, so product of 2 and a number, so I'm going to do 2 times x. And then I see is less than. So I say there's that is. So that's not a minus anymore. It's got is, so it's some kind of either inequality or equation, but it says is less than. So I got to use an arrow here. And I want the 2x to be smaller, so I point at it. I point at that. The 2x is less than the quotient. Quotient means divide. And we want to divide this stuff over here. So what's this stuff we're going to divide? 3 and this, oh my, 3 and the sum of 6 and a number. Well, I see sum, and if you go back, I said sum was a keyword. You're going to want to use parentheses. Stuff after the sum goes in parentheses. So you want 6 and a number. So sum means plus, and I need parentheses. So sum of 6 and a number would look like 6 plus, and it actually says the number. So that means it's this same thing over here. So this number is x. Right? So I want to add those up, 6 plus x. That's what this part over on the right is saying. But then if I go back, it said the quotient of 3 and this stuff. Well, then quotient means divide. Okay, so you could write this if you a couple different ways here. You could say 3 divided by, and remember I said sum over here, so you'd have to put 6 plus x in parentheses, like that. Or you could write 2x is less than, and you could just put the 6 plus x on the bottom and have it look a little tighter. Stuff on the right, that's how this stuff over here, that's how problems will look like throughout this course. Number 3, you give $500 for your birthday. Wow, lucky you. I never got $500. You decide to spend it on a daily trip to Caribou. You get your favorite beverage. Maybe this applies to you, maybe not. I'm not a big coffee drinker, but I can see how I see a lot of people drinking types of beverages like that on a daily basis, so it makes sense to me. Identify what your variable is and what it stands for in your expression. Well, variable is the thing that varies. It's the thing that's actually going to kind of decide where your problem goes from here. So I've got $500 and it's going to change because I'm going to buy stuff. What determines how it changes? Let's see, what determines how it changes? I guess it's my trips to Caribou that make it go down, right? If I go buy a beverage, my $500 is going to start going down. And if I keep getting the same beverage, as long as they don't change the price, it's going to go down by the same amount, right? So you could say that your variable, whatever you want to say C. C stands for Caribou, or you could call it T for trips to Caribou, or if you just want to keep using X, whatever. Okay? Or you can use maybe day, because it's a day, you're going every day, right? So let's just go with day. It's a daily trip to Caribou. So I would say that D stands for the days I went to Caribou, because that's going to determine what happens to my $500. Okay, write an algebraic expression that represents the amount of money I've left after going to Caribou for any number of days. Well, I had 500, and it's going to go down, right? So I'm going to have 500, and I'm going to lose some. But what am I going to lose? Well, I don't know, because I don't go to Caribou, so I don't know what it costs. But maybe you do. And you have a number in mind. Or maybe you know how to look things up. And you do a little Googling and you're like, hey, Caribou prices. And then here you go, and you can kind of scroll down and find your favorite drink. Alright, I don't want to get too crazy here. Let's say my favorite drink is a medium mocha for $4.29. So I'm going to lose $4.29 every day. Well, kind of. It's actually going to be more, right? Because I believe coffee is taxed. So you'd have to figure out what that price is. I'm not going to get into that, but we can figure it out. The tax rate in Elk River, if that's where you're at, is 7.875%. That's a lot, really. It's a little plus 10%. So you're $4.29. If you did 10% of that, that'd be like 43 cents. So, it's 30-some cents that you're going to add on to that. So you're probably paying around $4.60. Let's just use $4.60. Okay? If you're really interested, figure out what it is. Again, the tax rate, if you live in Elk River, this is it. And we were going with a $4.29 mocha. Medium mocha, see if you can figure out what the final price is. I contend it's probably right around $4.60. Maybe some of you had your favorite drink and you know. Alright, so I'm going to lose that every day. Now, if I lose something every day, that means that it's like going to compound by the same amount. Probably shouldn't use the word compound, but you're going to lose that same exact amount every time. When you lose or gain something that many times, you just simply put and multiply it by however many times you lose it. So if I lose $4.60 once, it's $4.60. If I lose it twice, it's 2 times $4.60. If I lose it 3 times, it's 3 times $4.60. If I go for a full week, it's 7 times $4.60. Okay? So I'm going to subtract $4.60 for every day I go. There's your expression. This is the model. I wasn't looking for an answer. I was looking for a setup that I could find an answer for if I had a question. And what would your question be? You choose a question, one that feels right to you. I'll ask you in class. those of you that are with me, what you think a good question would be. Those of you at home, what's a good question? What would the answer be? Okay, and then here's one last problem. I want you just to go ahead and write down what you would put for each thing, what your variable is. See if you can come up with an expression and see if your expression makes sense to you. Okay, so either pause it here and try to do that, and then I will actually post an answer after that. Give it your best shot. Welcome back. Let's see how you did here. This is what I came up with. I'm guessing some of you probably put 6 plus 7 in. Do you know why that's bad? Hopefully you tried a number and it didn't make sense at the end. But this one's tricky because the units are different. You've got hours and minutes, so you can't just put them together like you might have thought. So what I came up with is one down here where, ends the number of snoozes. You're a crazy snoozer. I said 6 snoozes. That's a lot of snoozes. It's a lot of Alexas. Take snooze. But on this one here, I said n is 6, and then I got 6.7 hours. Over here, I decided to convert it all to minutes. I said, hey, there's 60 minutes in an hour, so I got 360 minutes of sleep. Right? 60 times 6, or 60 times 6, so that's where this came from. So this would be minutes. Okay. If you have questions on that, feel free to reach out to your teacher. Sorry for the length here, got a little long. I was just excited to get back to work here and throw some stuff at you. Hopefully you found it valuable. Reach out to your teacher if you have any questions. Have yourself a wonderful day.